Day 632 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1,200, minimum absolute difference. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given an array of distinct integers R, find all pairs of elements with the minimum absolute difference of any two elements. Return a list of pairs in ascending order with respect to pairs. Each pair A, B follows A, B are from R, A is less than B, and B minus A equals the minimum absolute difference of any two elements in R. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So, in example 1, we have our input R equals an array of integers 4, 2, 1, and 3. So what we want to do is find all the pairs in this array that have the minimum absolute difference, meaning they have the smallest value when we subtract one from the other. So, the output is a 2D array of integers. First array is 1, 2, next array is 2, 3, and the third array is 3, 4. It says the minimum absolute difference is 1. List all pairs with a difference equal to 1 in ascending order. So all they did was looked at each pair in this array and tried to figure out which two elements we can subtract from each other to get the smallest absolute value, right? So if we did this pair right here, 4 and 2, that would give us an absolute value of 2. If we did 4 and 1, that would give us an absolute value of 3, right? But if we did 4 and 3, that's going to give us an absolute value of 1. Or if we did 3 and 4, because A has to be less than B, right? So if we did 3 and 4, that would give us -1, which is the absolute value would be 1, right? Because the absolute value is how far away is the number from 0. So if it's -5, the absolute value is 5, right? Or if it's -5 or +5, the absolute value is 5. We just want to know how far away is it from 0, right? So we could do 1 and 2. That's going to give us -1 as well. Absolute value of 1. Same thing with 2 and 3 and 3 and 4, right? So that's why we picked these three pairs, because that's going to give us the smallest absolute value. Once again, if we would have did these two pairs, that would have been 2. If we would have did 1 and 4, that would have been 3. Since 1 is smaller than 2 and 3, that's why we went with these, because these have an absolute value of 1. Now, just in case that didn't make sense, let's take a look at example 2. In example 2, we have our input R equals an array of integers 1, 3, 6, 10, and 15. This time the output is 1 and 3. So as you can see, 1 minus 3, that's going to give us that's going to be 2, or -2. That's going to have an absolute value of 2, right? If we did anything else, it would be greater than 2, right? So if we did 6 minus 3 or 3 minus 6, that'd be 3. This would be 4. This would be 5. Say we did 3 and 15. That's going to be 12. As you can see, no other pairs are going to have a smaller value than 2, or absolute value than 2, or a smaller difference than the absolute value of 2. So let's take a look at example 3. So in example 3, our input array of integers our input is R equals an array of integers 3, 8, -10, 23, 19, -4, -14, and 27. Once again, our output, or not once again, but our output is a 2D array of integers -14 and -10. Then the second array is 19 and 23, and the third array is 23 and 27. As you can see, all of these have an absolute value difference of 4, right? So 14 minus -10, that would be -4. Absolute value is 4. 19 and 23, that has a difference of 4. 23 and 27 also has a difference of 4. So these all have the smallest, or the minimum absolute value of 4. Anything else would be largest, right? 3 and 5 would be 8. Say we did 19 and -4, that's gonna be 23. You know what I'm saying? We could go 19 and 27. That would be 8. Nothing would be less than 4. So that's why we return this to the array of integers right here. So now that we understand the question, it's time to get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we're going to do is we're going to create a variable that will store all of the pairs that have the minimum absolute difference, right? So we need to create this 2D array to store our answer in. So we're going to declare a variable called result. We'll say colon, it's going to be a 2D array of integers, so square bracket, integer, and we can initialize it with a blank array like that. Next, we're going to sort the array so that the smallest differences will occur between adjacent elements. So we're going to say let sorted equal r dot sorted, just like this. Boom. Then we're going to track the smallest difference found so far by declaring a variable called minimum difference and set that equal to int dot max. Boom. Then we're going to iterate through adjacent elements in the sorted array. So we're going to say for index in 0 dot dot less than r dot count minus 1. We're going to open up the brackets. We're going to say let first equal sorted square bracket index. Boom. Then we're going to come underneath that. We're going to say let second equal sorted square bracket index plus 1. Boom. Then we need to compute the absolute difference between the two values. So we can come underneath this. We'll say let difference equal max, open up the parentheses first, comma second. Come outside of that, we're going to say minus min, open up the parentheses first, comma second. Boom. Then if a new smaller difference is found, we're going to reset the result list with the new pair. So we're going to come underneath this and we're going to say if difference is less than minimum difference, we're going to open up the brackets and we're going to say minimum difference equals difference. Boom, just like that. Come underneath it, we're going to say result equals square bracket, first comma second. Boom, just like that. Now, if the difference matches the current minimum, we're going to append this pair to the result list. So we'll come right here. We'll say else if difference equals minimum difference. We're going to open up the brackets. We're going to say result dot append, open up the parentheses, square bracket, first comma second. Boom, just like that. Now, we still need to come down here because we need to return all of the pairs that share the minimum absolute difference. So we need to come right here and we need to say return result. Boom, that should be all she wrote, y'all. Let's give it a run. Make sure it runs correctly before we submit it. Okay, can I find different? We need to add an E. Let's go ahead and add that E and keep it moving. Let's see. It's accepted. Boom, let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, y'all, what we looking like, and look at that, y'all. 16 milliseconds beats 43.6% of users, or 0.06, percent of users with Swift, y'all. So, with that being said, before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.